This is Brian Murray. I want to welcome you to another episode of Doc Bry, the Physics Guy. My kids have started asking me questions about physics and it's causing me some concerns. See, I'm not really into lying to my kids or giving them half the story, but when it comes to physics, it can be a bit tricky. I mean, just take mass, for example. Mass is one of those things that's really obvious until you take a really close look at it. And when you do, you realise just how little we know about mass. See, you understand what a pound or a kilo of sugar looks like, a pound of butter or 100 grams of coffee. It's more than that though, especially when you get down to the atomic level. Most people have the idea that the atom is like a solar system with like a little nucleus that's surrounded by electrons, and most of the mass is in the nucleus and so on, and these things are like a cloud. But what exactly is this mass? See, physics has an interesting dilemma when it comes to mass, because for one thing, there seems to be two different types that just happen to be exactly the same. Yeah, so we've got two different types of mass and they seem to be identical. And now you're probably thinking, dude, you're not making any sense. What am I talking about? Stay with me. I'd like to say it'll all become clear. It won't, but you might get some idea. See, it all starts with our man, Sir Isaac Newton. Now, he figured out that we can represent inertia using a really simple equation, and it's one of my favourites. It's Newton's second law of motion. Force equals mass times acceleration. F equals ma. I'll go into that equation in detail another day because it deserves a session all on its own. I mean, it's an absolute beauty and it's so profound. But for now, we're just going to go along with force equals mass times acceleration. And this is what we call inertial mass. Right, the result of this is that it's a lot easier to push a kid's buggy than, say, a Sherman tank. And this is because of the difference in mass. Physics guys call this inertial mass. This mass, though, also has a rather interesting property. It creates gravity. All mass bends space-time, and Einstein realised that if this was true, it would give us gravity. It's true that small objects create very small gravity, and even large objects produce relatively small gravity. The Earth, which despite what many people think when they say it's small compared with the size of the universe, is massive. I mean, you try walking around it, it's huge. Yet the gravitational field it produces is really small. It's so small that I can jump off the Earth. Anyone can, even little kids. Just jump in the air. You're actually defying gravity, the gravity produced by this entire planet. Granted, it pulls you back down, but for something the size of the Earth, which is huge, we're able to jump and defy gravity relatively easily. This type of mass we call gravitational mass, and we have a different equation for this one. And this equation is related to Newton's law of gravity. And it does look far more complicated. And the first time you see it, it looks scary. When it comes to equations, it's a scary equation. But once you get to know it, it's a bit like a big dog. You sort of learn to love it, you know what I mean? And you think it's great, but at first it's definitely a little bit on the intimidating side. You do a search on Google for Newton's law of gravity. If you've never seen it before, it's going to rattle you a little bit. See, in that equation, the mass that they're talking about is typically, say, the mass of the sun and the mass of the moon or the earth. But they talk about the gravitational mass. See, Einstein worked out that if inertial mass and gravitational mass are the same, then he could do something really clever, which ended up with his theory of general relativity. And to have an idea that gravitational mass and inertial mass are the same, and to do what Einstein did, is staggering. I mean, it's brilliant, and I look forward to taking you through general relativity one of these days because it's a mind blower. Although it looks like Einstein is right, there's no real reason why it should be this way. But from what we can see, inertial mass and gravitational mass are exactly the same. Now, you may be listening or watching this and thinking, surely we're just splitting hairs on this one. And that ultimately, that may be the case, though we've no real reason to think that gravity and inertia should be related. And if they're not, then we do need two different types of mass, gravitational mass and inertial mass. Now, if I'm honest, I think they are exactly the same, and I think that gravity and inertia are the same. It's not that they seem to be the same, they really are the same. I mean, I'm happy to put my head up above the parapet on this one. I mean, I think they are exactly the same, and I think that tells us something really important about the universe. But that one, and my idea for that one, is definitely going to have to wait for another day. Again, to end this one, and this is what is odd and puts a smile on my face. The truth is, we don't really know what mass is. And even though we may have discovered the Higgs boson, which seems to give us some clue into the nature of mass, we're still unable to say why the proton has the mass it does, or why the electron is so much smaller in mass than the proton. We do know a lot about the way it behaves, and we can control it. I mean, throw a ball. We all know how to throw a ball from one person to another. That, in a way, is controlling mass. You're controlling an object. But like time and energy, we're not really sure what it is. Again, this might seem a bit of a duff answer, but don't see it that way, because, like I tell my kids, what it shows is that there's still loads of unknown physics. There's so much to be discovered, and who knows, it might be you who figures it out. I'm Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, can you share it with your friends, your fellow students, and anyone you think might be interested? That'd be great, and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news, and check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com, drbry.com. I look forward to seeing you soon.